Hello friend, today we are going to learn the classical mechanics unit first, and my point is integral of motion. Let F is equal to F of Qi dot be the function of generalized coordinate Qi and generalized velocity Qi dot. Means Qi is generalized coordinate and Qi dot is generalized velocity, and if this F remain constant during the motion of the system and depend on the initial condition, then such a function F is called integral motion. This is the integral motion definition of this. Means F is the function of generalized coordinate and generalized velocity. Then second is the Lagrangian formulation and Hamiltonian formulation. Lagrangian equation of motion for a conservative system you are known d upon dt into del L upon del Qi dot minus del L upon del Qi is equal to 0, and here I is equal to 1, 2 up to the term n. In Lagrangian formulation, the mechanical state of the system is given by its generalized coordinate Qi, and this is Qi and Qi dot. However, this is not only the possible way to describing the state of system. Another way of specifying the state is through the generalized coordinate Q and generalized momentum P of the system. This leads to the change from Lagrangian formulation to Hamiltonian formulation. This transformation is provided by the Lagrangian transformation as Q dot tend to QP. Here del L upon del Q, that is this is the momentum, and here Qi means del L upon del Qi dot, and that is represented P. The quantity Q and P, this quantity QP are known as the canonical variable or coordinate. Here Pi is equal to del L upon del Qi dot Qi dot T is the generalized momentum or conjugate momentum. Means this Pi is the function of Qi dot and T. The Hamiltonian procedure does not decrease the difficulty of solving any given problem in mechanics. It gives the equal status to coordinate Q and momentum P as an independent variable. And here Hamiltonian formulation is an alternative to the Lagrangian formulation, but proved to be more convenient and useful, particularly in dealing with the problem of modern physics. Hence, all the problems solved by Lagrangian formulation can also be solved by Hamiltonian formulation. Then Hamiltonian function. The quantity is summation Pi qi dot minus L expressed in term of generalized coordinate q and generalized momentum p and time t is called Hamiltonian and it is denoted by S. Thus, we have h of pi qi t is equal to summation I pi qi dot minus L, and here I is equal to 1 to L, and that means H is equal to summation PQ dot minus L. That's it, the Hamiltonian function. That is the Hamiltonian function. Thus, the Lagrangian transformation of the Lagrangian L with change of sign is Hamiltonian H. Then Hamiltonian canonical equation. The Hamiltonian canonical equation is derived from the Hamiltonian function. Therefore, first write the Hamiltonian function, and Hamiltonian function is given by above, that is H is equal to summation PQ dot minus L, and here H is a function of pi, qi and t. Then write the H of pi qi dot qi and t is equal to summation I pi qi dot minus L of qi dot t. Here pi and qi are the that is pi and qi are generalized momentum and generalized coordinate respectively. From what we get derivative of this means dh is equal to derivative of this whole bracket pq dot minus L, summation pq dot minus L, and here separate this term and write derivative of summation of derivative of pq dot minus summation of derivative of L of qi dot t. Then the product rule is used. Then summation of pi into del qi dot plus qi dot into dpi minus summation of, again derivative is used, del L upon del qi into dqi plus del L upon del qi dot into dqi dot plus del L upon del t into dt. Means here product summation derivative of pi into qi dot, that is first function into derivative of second plus second function into derivative of first, and here L is a function of L is a function of qi and qi dot and t. Means again first derivative of L with respect to q, then derivative of L with respect to qi dot, and third derivative of L with respect to t. Then write the summation pi dqi dot plus summation qi dot dpi minus summation, here del L upon del qi is equal to pi dot. here minus and this minus sign is multiplied by whole bracket, then all the term of bracket is minus, then del L upon del Qi is equal to Pi, means summation Pi del Qi minus summation Pi dot into del Qi dot minus del L upon del T into dt. Here del L upon del Qi is equal to Pi dot and here del L upon del Qi dot is equal to Pi and del L upon del Qi is equal to Pi dot. These are given, and then dH is equal to summation of Qi dot dP, because this term and this term cancel, and then we get Pi dot this term is cancelled, then we will get summation of Qi dot dP minus summation of Pi dot dQi minus del L upon del T dt. This is equation number 2. And also we know H is a function of H is equal to H is a function of Pi, Qi and T, and this implies that dH is equal to dH upon differential partial differentiation del H upon del Pi into dPi plus del H upon del Qi into dQi plus del H upon del T into dt. That is equation 2. 3. Compare 2 and 3. 2 and 3. We get del H upon del Pi, this term del H upon del Pi is equal to minus Qi dot, and del H upon del Qi is equal to minus Pi dot, and del H upon del T is equal to minus del L upon del T. This the first two equations are known as the Hamiltonian canonical equation of the motion. Then we see the Hamiltonian principle. This is the most important topic in this unit, that is Hamiltonian principle. The Hamiltonian principle is stated as the motion of the dynamical system from time t1 to t2 such that the line integral t1 to t2 L dt is extreme. This means that a small deviation in actual path followed by the system is zero, and mathematically it expressed as the derivative del of t1 to t2 integral t1 to t2 L dt is equal to 0 and that is del of T1 to T2 summation of value of L is summation of PQ dot minus H dt is equal to 0, and this is the Hamiltonian principle. Equation of the Hamiltonian principle means Hamiltonian principle is the motion of the dynamical system from time t1 to t2 such that the line integral is equal to 0, or this line integral is extreme, and this means that the variation in actual path followed by the system is equal to 0, means put the value of L is equal to summation of PQ dot minus H and this integral, and that variation means derivative that is equal to 0, and this is the Hamiltonian principle. Then we take the derivation of Hamilton equation of motion, then Hamilton principle means obtain the Hamiltonian equation of motion from Hamiltonian principle. We know the principle, then find the Hamiltonian equation of motion. Then write the proof. First write your known. You know the Hamiltonian principle. The integral T1 to T2 L dt. Value of L is summation Pi Qi dot minus H dt is equal to 0. This is the Hamiltonian principle. Here H is a function of Pi, Qi and T is the Hamiltonian function, and from 1 we get integral T1 to T2 summation of Pi into derivative of Qi dot minus plus Qi dot into derivative of Pi minus del derivative of H into dt is equal to 0. And then means here product rule is used, derivative of this function and separate this two term, and derivative of this product rule is used, first function into derivative of second plus second function into derivative of first. Then write integral T1 to T2 summation Pi into there, and Qi dot means del Qi derivative of dqi upon dt plus summation Qi dot del Pi minus summation del H upon del Pi minus del H upon del Qi into del Qi dt is equal to 0. And integrate the first term by part, then we get means these two term are interchanged, and then that is integral of T1 to T2 summation pi d upon dt del qi dt plus T1 to T2 means separate this term summation qi dot del pi dt minus T1 to T2 summation of del h upon del pi into del pi plus del h upon del qi into del qi is equal to 0. We integrate this first term by using integration by part. Then we get the integral summation of pi into del qi means first function into integration of second minus T1 to T2 minus integration of derivative of first. Derivative of first is pi dot into integration of second del qi into dt T1 to T2. Integration by part is used, and then this term is right. Summation of pi into del qi T1 to T2 minus integral T1 to T2 pi dot del qi del t, and then implies the summation of pi del qi at time t2 minus pi del qi at time t1 upper limit minus lower limit minus t1 to t2 pi dot del qi dot del t, and that implies this value is 0 minus summation integral t1 to t2 pi del qi dot del t, and because del qi at time t2 and del qi at time t1 is equal to 0, and then the minus summation of integral t1 to t2 pi dot del qi into dt is, that is equation 3. From 2 and 3, from these 2, 3 and 2, we get minus summation of integral t1 to t2 pi dot del qi dt plus integral t1 to t2 summation of qi dot del pi dt minus integral of t1 to t2 summation of del h upon del pi del p plus del h upon del qi del qi dt is equal to 0, and then take out the minus summation and outside, and then minus summation integral t1 to t2 pi plus del H upon del Qi into del Qi dt plus T1 to T2 Qi dot minus del H upon del Pi into del Pi dt is equal to 0, and this implies that the T1 to T2 summation Qi dot minus del H upon del P into del Pi minus Pi dot plus del H upon del Qi into del Qi dt is equal to 0, and since del Q is arbitrary and hence del Qi different from 0, del Qi is different from 0, and then this implies that the summation of Qi dot minus del H upon del Pi into del Pi minus Pi dot plus del H upon del Qi into del Qi is equal to 0, and here del Pi and del Qi are arbitrarily, and hence Qi dot minus del H upon del Pi is equal to 0, and Pi dot plus del H upon del Qi is equal to 0, means del H upon del Qi, del H upon del Pi is equal to Qi dot, and del H upon del Qi is equal to minus Pi dot, and which are the required, these are the required Hamiltonian equation of motion, that is the required Hamiltonian equation of the motion, that is del H upon del Pi is equal to Qi dot, and del H upon del Qi that is equal to minus Pi dot, that is the Hamiltonian equation of the motion.